Hello, Math 2 students. Today we're going to do some multiplying, and that's going to help you to understand how to use the right signs when you're factoring. So we're going to connect what we know about multiplying to what we wrote down about finding the signs of the factors of a polynomial. So we're going to start out with this one here. We have a x plus 5 and x plus 5. So when I look at my first terms in each set of parentheses, that's going to be x squared. And then I'm going to take a look at my outer terms. So x is an outer term and 3 is an outer term, so that's 3x. My inner terms, 5x and x make 5x. And 5 times 3 is 15. So we have x squared plus 8x plus 15. So right now, this is what I want to look at. Our C value is positive. Our C value is positive. And when our C value is positive and our B value, 8, is positive, then we're going this way on the chart. And we know that in factored form, we will have a plus sign for both of our binomials. So one quick rule that you can always remember is that when you're factoring, if the polynomial you're factoring doesn't have any minus signs, if it's only positive, then your two factors will always be positive. So this is the kind of problem that's a dream come true if you don't like positive and negative numbers. Any problem that only has positives in it will only have positives when you factor it. Okay, now what happens if both of the signs are negative? So I'm going to multiply my firsts and I get x squared. I'm going to multiply my outers and I get negative 3x. I'm going to multiply my inners and I get negative 5x. And then when I multiply my lasts, I get positive 15. So my answer is x squared minus 8x plus 15. So this time our C value is positive. That puts us right here. Our C value is positive. But our B value is negative. So if our C value is positive and our B value is negative, we know that when we find the two binomial factors, they will both have a negative sign in between. And that's what happened there. Now, how was our B value negative? Well, if we take our outers and our inners, they both come out to negatives if you have negative signs here and here. So that'll make negative 8x. Also, if we have a negative times a negative, that will make positive 15. All right, and finally, what if we have x plus 5 and x minus 3? When I multiply the firsts, I get x squared. When I multiply the outers, I get negative 3x. When I multiply the inners, I get positive 5x. And when I multiply the last, I get negative 15. So my final answer would be x squared plus 2x minus 15. So now we can see our C value is negative. So over here we were dealing with problems where the C value is positive. Positive 15, positive 15. But now our C value is negative, negative 15. Well, the only way to multiply the lasts together and get a negative 15 for the answer is if the signs are different. If these were both positives, we would get a positive 15. If these were both negatives, we would get a positive 15. But if you have a negative C value, your signs have to be different because the only way to multiply and get a negative number is to multiply things that have two different signs. All right, so I wanted to do one factoring problem where the C value was bigger. A lot of the examples we did had C values that were prime numbers, so it was almost too easy to do the problem because there was only one pair of numbers that could multiply to give you C, 1 and whatever that number was. 32 has more factors. There's more ways to multiply and get 32. So I wanted to do this example. So I'm going to start out by setting up my two binomials. And I'm going to put blanks for my 4 terms. And now my C value is negative. So I'm going to be going to the left on the notes. And my signs are going to be opposites. The only way to get negative 32 is if I multiply a positive times a negative. So I'm going to use reverse foiling to help me figure this out. And to start with, my first term here is x squared. So when I look at my firsts, I need two numbers that can multiply together that will give me x squared. Well, there's only one way that will work, x and x, because our a value is 1. Now I need to figure out my lasts. My two last terms need to multiply together and give me negative 32. The reason this problem is more difficult is because there's more ways to multiply and get 32. So I'm going to come over here to the land of opportunities. One opportunity that we have is to use 1 times 32. Another opportunity that we have is 2 times 16. And another opportunity that we have is we can use 4 times 8. Now, what we need to happen here is we need to multiply these two numbers, and they do need to come out to negative 32. But when we look at our outer and inner, we need those to come out to the middle term, which is negative 14. So we need numbers that multiply to negative 32, but are going to add up to negative 14. So right here, if I take 1 and 32, the sum is going to be 33. The difference, if I subtract them, is going to be 32. Here, 2 times 16 is 32. If I add them, the sum will be 18. And if I subtract them, the difference will be 14. 4 times 8 is 32. If I add them, the sum is 12. And if I subtract them, the difference is 4. So which combination should I use? 1 and 32, 2 and 16, and 4 and 8. Well, the only combination that has a chance of multiplying to negative 32, but of having a sum or difference of 14 is those numbers right there. So I want to use 2 and 16. So I'm going to put the 2 here and the 16 here. And so 2 times 16 is negative 32. So my lasts are working out correctly. Now, my outers, negative 16 times x is negative 16x. And my inners, 2 times x is positive 2x. And when I put those like terms together, I get negative 14x. So it looks like I have factored this problem correctly. So before I'm satisfied that I have the right answer, I'm going to do a quick table check. So here's my table. I have x plus 2. I have x minus 16. Those are what I think are the right factors. I multiply and I get x squared. This is negative 16x. This is 2x. And this is negative 32. So when I take everything out of my table, I have x squared. These are like terms, so that makes negative 14x. And we have negative 32. And since this is the same as the problem that we started with, we know that we got the right answer. So we factored to get these binomials. That's the answer. But to check them, we took our binomials and multiplied, and we got this second degree trinomial, which is the original problem. So we know that we did it correctly.